Cast, kicking you in the balls.
You're right.
I had one of my son's friends today. He said that he speaks Canadian. I was like, oh yeah. I was like, I want to talk to my friend Cory and try to find out what speaking Canadian is because
yeah, I'd love to know.
last time I heard that there is no Canadian language. I think we're live. All right, we're live. What is up, everybody? I tried to make it on time tonight. That's why I scheduled a little bit later because I just got home a little bit. What is up, everybody? Welcome, Mr. Cory and Steve. Mr. Steve. I'll start calling you both Mr. That way.
There you go.
I don't get my balls busted.
Yeah.
But yeah, man. I guess we'll start off real fast and just say, how are you guys doing, man? I know it's getting busy. It's go time. I guess we'll start with age before beauty. Go ahead, Cory. Just kidding.
You know what? It was chaotic. Like, believe it or not, it was all last week. We were about 90 Fahrenheit to about 104 Fahrenheit with humidity, and that's our spring startups. So we don't normally get hit that hard with that type of weather. So it was chaos. I mean, work was just insane. And I woke up this morning or yesterday morning and it was 36 Fahrenheit. So it's like, come on, weather, make up your mind, baby.
Goddamn Canadians.
Yeah, but it was fun. It was a nice blast of tons of no cools. So I had fun. Lots of videos I made.
Nice.
Yeah.
How about you, Mr. Steve?
We're just cranking up. We've been hanging in the low 80s, but we got the 90, 92, 93 coming in by Thursday, Friday. So it's cranking up. Humidity's just getting ready to crank up. Been doing a lot of water leaks. Those are already coming in and driving us nuts, but got a couple of newbies out there running around trying to catch up what we can't catch during the day. So getting some training by Facebook in. So we're having a fired up. Install department is wide open, which is crazy.
Nice.
You know, service isn't probably as big as we thought, but it'll come around.
Nice. Hey,
It's money making time.
both of you, make sure you have your microphones turned up and then I'll control it. Some people are saying that you guys are quiet. So I turned you up a little bit. Thanks for the feedback, guys. Remember, in the beginning of these, if anything seems like it's not loud enough or something, just let us know, because doing the different streams with different people and different mics, I have to adjust it. So sometimes I have to adjust it back. But what is up, everybody? Thank you. What's up, Marcus Mitchell? Thanks for seeing you in here, buddy. Yeah, here, man, it's like I told you guys off air, man. It went from like 0 to 100 in a weekend. It's going to be 90 plus here tomorrow, and we've been busy before this. It started with all the maintenance and different things. We had some sales calls, which I've been killing it. Yeah. You know, today was like 38 grand in sales. But yeah, it's starting off good. We kind of need it because it was a very shitty winter. So kind of need the summer to be profitable. So as always, we need more people. Can't find good help. I think that's the way it is for everybody.
It is. It is.
But we tonight we are going to talk about airflow. It's something that the three of us have talked about quite a few times, and we all know that, you know, guys starting out, airflow is a very, very big one for people to grasp their head around, because there's so many aspects of it that they get confused. You know, can we agree? Most of us are taught, you know, when you're younger, that you want to, you know, a delta T or a temperature split of, you know, 18 to 22 degrees.
Yeah. Yep.
Okay. But, you know, what these guys fail to realize is they don't know what it means if it's too high. They don't know what it means if it's too low. And then you start throwing humidity into the play, and these people are like, what? That does what to the temperature?
Mm-hmm.
So you could have a 14-degree split on a very humid day on certain systems, and there's nothing wrong with it.
Yep.
So I guess whichever one of you wants to take the mic, I don't know where one of you would like to start. I don't want to put you guys on, I guess, so it's not just me running my mouth.
But you're good at it.
Yeah, you're the best at it.
Yeah, so I guess, I'm trying to think when you talk about the basics of airflow. So first of all, starting with airflow, we have to make sure that we have a clean system first and foremost. All right. So this is why we always say that maintenances are so important. When you go out, that blower wheel needs to be clean. Okay. They say 1/8 of an inch of dirt can reduce airflow by up to 40%. All right. Mm-hmm. So I see so many people, they see just like kind of a layer of dirt on it, and they're like, oh, it's not a big deal. But it is a big deal. Okay. That little things can take it off. Is your filter clean? Is your, all your vents open? Your returns aren't blocked? Is the coil dirty? That needs to be things that you look at first and foremost before you can ever start measuring any kind of airflow, taking any kind of temperatures, because otherwise you're just kind of setting yourself up for failure. You're not giving yourself accurate readings. I mean, do you guys agree with that? I mean,
100%.
Yeah, I like to take it back to the first of commissioning a system. When it's first installed is the groundwork for your airflow and checking static pressure when that system is brand new and clean. I got a ding. Somebody hear a ding? But anyway, we had the today shop on static pressure and measuring total static external pressure.
You are over there?
Yeah, I'm hearing a bunch of ding on over here. I don't know what's up.
I thought Steve had a poor stroke there for a second.
Yeah, I was gonna like call 911.
He's having a stroke, ladies and gentlemen.
I actually watched a podcast this morning or a video on taking static pressure as I was heading into work. And once I got to the parking lot, a lot of the guys told them what was going to talk about this morning. And they were just blown away that there was going to be a topic on that. They have no idea on even how to measure static pressure and how to read the manual on static pressure, the blower data chart. And I'm a guru at this by any means. I have seen hundreds of blower charts in my career, and just up until the last 3 years did I understand all this. So somebody that's been doing this over 30 years is just now getting into it and grasping it. I know it's an issue without a doubt, because I was never taught that. They didn't teach that in school, and all the schools that I went to and classes I went to, it was variable speed, set the dip switches, and walk away. And I think we need to address that, and how to check static pressure with manometers. Make sure everybody has manometers. Do they know what manometers are and what kind of pressures do they read?
Yeah, I think you made a good point there, Steve. I think the main thing is you want to benchmark your units right off the bat. And I think for new guys, I listened to Bill Spohn, and he made a good point. Measuring airflow is easy, but measuring it accurately is hard.
Amen.
And there's so many ways that we can measure airflow. I mean, I went through, when I was new, an abundance of videos with different tools that we could take. You have your vane anemometers, you have a hot wire where you traverse the duct. You've got static pressure. I mean, there's numerous ways. Blower hoods. And I think for new people and new guys out there, one thing that you could start early is just get used to static pressure. Okay. Get used to taking your static pressure and do it on a new install or a commissioning, or if it's a brand new customer and it's the first time there, take your static pressure. And there's lots of charts out there. In fact, I sent one. I have one. If you go on HVAC, HVACrschool.com, and you go under their resources tab, there's a static pressure worksheet in there. It shows you exactly where to drill your holes, and it has a chart where you could write what your static pressure is on the original commissioning. And that makes your life so much easier down the road when you reference the original benchmark. You know what I mean? Because as time goes on, it's going to save you a ton of time. And if your evaporator gets dirty or all of a sudden your returns are blocked, you're going to see that if you reference it. So I think for new guys, just getting used to taking static pressure and reading a blower chart is the start. You know, if you could do that, it's pretty accurate. It's pretty easy. And I think that would be the first thing to get used to.
I agree. There's too many systems that are doomed from the start. That's the problem. And like you said, there's so many ways, and it's not that one way is wrong and one way's right. You know, there's more than one way to do it. But I do agree with you that static pressure is probably the easiest for most techs, because having a manometer is pretty basic for the most part. I mean, that's kind of on like the basic tools to get after you have your hand tools and gauges. You should probably have a manometer for gas pressure and static pressure. We do have a few hoods now that we've got that normally we're only giving that to guys if we know we have airflow issues and we're going to record the measurements. But I agree with everything that you just said. I want to bring up sorry, trying
That's
not
okay.
to pay attention to the chat, but Zach brought up a good one. Have you guys ever tested in and out after cleaning a blower wheel?
In and out as in what? The static pressure?
I'm not sure what he means. If Zach, if you're still in there.
What's your static pressure before you clean one, and what is it after?
Yeah, I mean, I have. I've had a call. Actually, I think it's on my channel. I had a carrier unit, and the static pressure was real high. They did a bunch of renovations, and the squirrel cage was caked, and it was so caked that it was wobbling the unit. And so I had to pull it, take it outside, wash it, clean it, and then I noticed the static pressure drop myself, and it makes a difference. And that's why it's important to ensure that if you're going to benchmark your unit via static pressure, you got to make sure it's clean. Like, don't bother doing it with a dirty filter in there.
Well, it kind of goes back to what we said about a few episodes or last episode about superheat and subcooling. There's no point in checking it if you don't know what it's supposed to be and if it's not correctly what it should be. It's the same with airflow. You need to know why we call for, 0.5 inches of, water column, like why we want it there. I mean, the basics for you people out there that don't know the basics, when you hook up your manometer, you have a positive side of the system, which is going to be your supply. You have a negative side of your system, which is the return. So if you have I'm just making up these numbers, negative 0.2, on your return, and then you have a positive 0.3 or whatever, and you put those together, that's going to give you your total external static pressure. But I guess I don't know if we want to get into that, like where to actually check
Stick your probes.
Yeah, exactly.
Do you have that work? I don't know if you could pull it up, Gil. If you have that static pressure worksheet, it might be in the email. It's actually Michael Hausch, who's moderator in HVAC school, and he created this worksheet, and it's perfect. It reminded me of a video I watched by, oh my God, his name's going to... Gil, who's the lives in a small house, goes around and does home improvement.
Nate Adams.
Big, no, the other one.
A little house that
He
Yeah.
lives in a
It's here in Atlanta.
yeah. He has a TV show now.
lives in a little house.
Someone in the chat's got to help me out. You know who I'm talking about. Him and his wife travel in a small house. They do home improvement, home performance. I think his channel is home performance.
Anyway,
Yeah, I don't
Anyways,
know.
I can't think of his name, but he has an amazing video on static pressure. That was the very first place I learned it. And his name will come to me eventually.
Somebody said Corbin.
Yes, Corbett Lunsford. That's him.
Way to go, Tommy Stevenson. Oh,
Good
Chris.
job, buddy.
Actually, the first one was Chris from HVAC Videos. Actually said his full name.
Yes.
Chris wins.
Yes.
And he has an excellent video. And you know what? It's crazy because I'll go into all these calls, new customers, and Corbett made a good point. You know, he said if you walk into a house and they don't have those static pressure holes already drilled out, you got to tell the customer they need to get someone else because there's evidence right there that it's never been tested. You know, and
That was the video I watched this morning. He says, you know, if your technician takes you down, owner, and you point out that there's no holes to the homeowner, they don't ever need to call that company back because they haven't done their job.
exactly.
So something I would like to see, and I know we can't do call, but just in the chat, how do we come up with that 0.5 number? What are some of the factors? What are some of the restrictions that give us that perfect 0.5 number if we could have it? What are some of the items in the system that bring us up to that number? You know, we talk about air filters a lot, that they're static robbers.
Many things. Yeah. Blocked returns, undersized ductwork.
Yeah.
Yeah.
Real fast to Zach. No, Zach, we know you don't have to test static pressure to verify. You can verify it in other ways. And Cory named off all the other ways. We were just saying that, you know, besides like your temperature split, that static pressure is probably going to be one of the easier ways for new technicians.
Yeah, ultimately, I mean, as a new technician, the easiest way is and I see it a lot, is a DC motor. It's going to spit out your CFM via the board. Technician goes down, looks through the spyglass, sees, you know, a 2-ton unit at 800 CFM. That's the easiest way. And I know there's a lot of techs that, even within my own company, yeah, if it's a DC motor, it's easy for them. But, you know, as a new technician, the way I was taught, and this is a Canadian thing, I don't know if it's the same thing in the US, but it made no sense to me. All PSC motors, all my journeymen would say, just make sure it's on black. So I would go down there and put it on black. And it wasn't until I watched the videos on the static pressure and pulled up a blower chart that I realized, well, that makes no sense because most of our Canadian systems are 2.5 tons, and I'm on black.
Yeah.
So, you know.
Man, HVAC Survival, he said he was always told we shoot for a 0.1. That seems like
That's at the bottom of the chart.
that's
I
like pretty low. I mean, you have to I mean, that has to be like no flaws, like flawless to be able to have a 0.1 total stern
That total, or is that just his filter?
yeah.
0.1, I thought was, you know, typical return ductwork is 0.1. And I think and your supply. So if you had your static probes directly in the return or the supply, should be about 0.1.
Yeah,
But
what
total external would have to be higher than that, I would think.
Yeah, well, that's what I was thinking. Total, that just seems
Corbin was talking that in the real world is 1 inch or 1 for your return, one for your filter. Usually your evaporator coil is going to be 2. If you take
give or take.
have 2, and then 1 up for your supply plenum. So you have 1 return, 1 filter, 2 for your coil, and then your supply is going to have a static of 0.1 as well. So there's your 0.5.
Sorry, Mr. Zach brought up a good point. Some people get it mixed up. 0.1 is normally your friction rate. Is, when you're, not your static pressure. It's your, your friction rate when you're trying to design duct work.
Yeah.
Well, that's where I think just basic technician entry level of knowing how to check total external static pressure is important. We can't do anything in the field other than take that measurement and understand where are we losing airflow. Are we losing it on the return side, on the supply side? We can measure above and beyond the coil, and we can measure our filter, and we can just gather these numbers, and then from there and the homeowner of where a problem is. And from there, we take it back to the office. Let the designers do it. Let the engineers, the people that run the computers and have the hood flow hoods, and come out and do true testing. But we can identify what part of the system. I've done some quick testing on the 3M filters, and those are killers.
Yep.
Mm-hmm.
I mean, they'll kick up a static pressure drop that's just blows you into the 1-inch zone total external just by taking that out and putting whatever you have on your truck, and you'll get it down into an acceptable range. You're not going to get down to 0.5, but you're going to get down into what the blower chart says. Most blower charts are going to be what? 0.1 to 0.9 is what manufacturers are going to say. You can work in that range. That 0.5 is like the perfect ultimate design. And
for a PSC motor. I know most DC motors, at least with Lennox, they're rated at 0.8. So if you look at their manuals, it's not a 0.5 on the DC motor. They'll all say 0.8. And then I think for heating, they said 1.0. But I mean, this all goes back to the basics. So I guess the point, what we're trying to get across is for the new guys out there, you want to start off with just reading your blower charts. I mean, that's the easiest thing. And you're going to have blower charts for a PSC motor, and you're going to have blower charts or fan charts for a DC motor. The nice thing about a DC motor is that's relatively easy. You're going to find, okay, what's your CFM? And that's another discussion, right? For new guys out there, is what is the correct airflow? It's one thing if they know how to measure it now, but what are they looking at, right? So where I'm from, it tends to be it's almost Florida type weather. So you got a little bit of a higher latent load. So we're looking at, 350 CFM per ton. And, where some guys from Arizona, you're going to have a more sensible load. So you're looking at 450. But so to get back to the basics, 2 ways. If you're a new guy out there, and you're either going to have a DC motor or you're going to have a PSC motor. If you have a PSC motor, start with static pressure. Look at the blower chart, and once you got your static pressure, you find that on the chart, and it's going to spit out a CFM. I mean, it's the easiest. It's going to get you by to start off. It's not the most accurate, but as a starter, that's where I started. It's the best thing that you can do. Same thing with the DC motor. DC motor, you're going to find your CFM per ton, find the airflow you need. You open up that manual, and you just go down, and it's going to tell you, do you want it on high, medium low, or low? And then you set your dip switches.
Yeah, well, I mean, even starting out with the basics, and guys don't get too far into it. Well, actually, let me backtrack. Mr. Steve, when you were talking about those 3M filters, when you have a filter that's clean inside of a unit, and you pull it out and you can hear the motor go, oh, you know that that's a problem. You know, there's something wrong there. You don't have to know do diddly ding dong about airflow, but you should know, common sense should tell you that's an issue. And it totally kills PSC blowers because they're too stupid to know, you know, they just keep chugging along and chugging along because they don't know to slow down, speed up, stuff like that. But with the DC motors and the variable speed motors, it can cause a problem because that thing is never going to ramp up completely because of that. Like I know the Infinity carrier systems, it measures static pressure. You know, I mean, you can go into the UI and see static pressure, and if you have a high static pressure, that blower is never going to run at full speed. It's going to run where it needs to not kill itself. And we've seen a lot of problems that way. And that's where we go back to commissioning, coming in to make sure that whoever your sales guy did a good job if there needed to be ductwork changes and stuff like that. But I don't know where I was going with that, but I thought about that filter. I wanted to make sure I pointed that in there. Sorry, I'm trying to find all your guys' photos you send me.
They're in there. But yeah, you know, one thing when variable speed first came out a long time ago, that was like the cure-all to ductwork problems. It's like, oh, put a variable speed in there and it'll fix ductwork issues that you have. And I know here in Atlanta that we found that to not be true. There's quite a few companies that went after that mentality, and they ended up having to go back and just start adding additional returns because most of the homes here in the Atlanta area just don't have enough return.
Mm-hmm.
I think the reason for that is, and I talked to my owner about it today, just hanging out in the back parking lot, is the way that they size the ductwork, particularly on tract homes, where they just come into a neighborhood and they slam up 150 homes in 6 months and they're out of there. I think that most of those installers were taught by Fred, and Fred was taught by Bubba, and Bubba put in hard duct. There wasn't no flex back then. So basically back then, a 10-inch duct could carry CFM a whole lot better than a 10-inch flex does. I think that we need to start really teaching and preaching and find a good number of what a 10-inch flex actually does move. You know, I know I've gotten so used to 400 CFM for a 10-inch, 200 for an 8-inch, 100 for a 6-inch, and it just doesn't happen these days. I ran across a couple of customers this week where they just had terrible flex ductwork, kinks going through prefab trusses and joists, and they twisted and kinked, and you count them up. He had a 2.5 ton, had 3 tons, 2.5 ton unit with 3 tens on a return, and he was boosting almost a 1-inch static.
I got all of your guys. Well, I got the ones that are in the email. Mr. Steve, if you got one of your pictures that you are wanting to show, I can pop it up on the screen. I got one of the blower charts right here.
I got the blower chart, and I think it has maybe a picture of the door with the static pressure written on it.
Yeah, total.
And a blower wheel.
Yeah, I can see that. Here, let me pump it up. Hold on.
So let's think. So basically, to start out, what do we need for a basic technician out there? He doesn't need to go break the bank and get, hot wires and flow hoods. I think basically your best bet would be get yourself a pair of, they have them at True Tech Tools, pair of static pressure tips. You should have a manometer, I would think. And, what else do you really need? Some nylon, some hoses, some tips, and a manometer.
Thermometers. Okay. 2-pocket thermometers. I mean, let's not forget that our Delta T, our taking our temperature, can tell us a good bit. I definitely think it's a small piece of the puzzle, but I think if taking it correctly, some guys, they take that temperature a little bit too close to the coil. I mean, give it a little bit of room. I always try to take that temperature. I was always taught when you're taking your return temp, take it before your filter and after your filter, just to see if there's any kind of, change. Normally, you should check the filter. If it's clean, you won't have it. But just something that I was taught. But moving your thermometer, don't always go in the canvas if there's canvas right above the coil, don't always go there. Try to go up a little bit after that air's been mixed and actually try to get a true temperature, because sometimes when you're so close to that coil, it can lie to you.
Yeah, and that's the whole topic of trying to get an accurate reading is hard. You basically want to make sure you're out of sight of that evaporator. That's the main thing. It's the same thing with heating side. You want to make sure that you're not getting any heat gain from the heat exchanger. But yeah, that's a good point, Gil. 2 thermometers could tell you a lot, right? Steve, if we have low airflow, what happens to our delta?
It's going to go up.
Yeah. So if you get to, I had a technician, and I'm sure it's happened. My buddy said, well, hell, it's cooling good. It was like 27 split.
Mm-hmm.
So right there, it tells you that if you have that high split, low airflow, and same thing with, if I don't know if you have that chart, you probably don't, but TrueTech Tools, again, guys, they have a lot of good resources out there. If you go to their website and you go to technical training, and you go under resources, there's a lot of little graphs you can get. So for the new guys out there, there's actually, it might not be TrueTech Tools. Actually, my apologies, but type into Google temperature split chart, and it'll show you based off your wet bulb and your return air, roughly what your target's going to be. And I think Zach did this on his channel. I think he called it teat or something like that. What was that, Zach? Anyways,
Zach had a good one, and it was a very good, the way he did his for people just learning. Yeah, you can Google. One very good chart that I recommend to newcomers is the super cool slide rule for them to keep in their bag. It's a whole bunch of basics things mixed into a little chart that can really help. And it's just a bunch of reference material put into all. There's an app now, but I think they charge for it, which is kind of bullshit. But there's a little. Go ahead.
You know who's doing something similar? Sorry to cut you off, but AC Service Tech came with his own cards. I think NorCal was giving them away the other day.
Oh, I'll have to. I talked to Craig not long ago, so I'll have to ask him. Let me get a few of those. But I guess let's back up for a minute, because we keep saying we're doing basics, and I think sometimes we get ahead of ourselves. So
because we got all the pros in the chat, so you
I know.
Sidelined here.
Yeah, teat. Yeah, Zach said teat. Target evaporator exit temperature. Explain to someone who doesn't know. Maybe they're not here live, but they're watching this video after the fact. What is the difference between dry bulb, wet bulb? How do you take the two? I'm the announcer, so you guys got to answer the hard questions.
Well, back in the old days, we would get a thermometer, a mercury thermometer. We'd cut a piece of our shoestring off, slide it over it, get it wet, and whatever temperature you got, your wet bulb.
Yeah.
Then this sling psychrometers were around when I first started. I've got one somewhere. But then all this electronic stuff wasn't out back in the day. And if it was so stinking expensive. I would just get my pocket thermometer. I literally get a piece of toilet paper, drape it over it, get it wet, and stick it in front of the return and see what I get. It's all I had to work with, but it was better than nothing. I was getting some kind of a reading, but what it was, I got up into the return, how do you get a piece of wet toilet paper in the return and measure? But I was doing something, walking around the house with it, getting some kind of a idea of actually what kind of a wet bulb instead of guessing at nothing. But with the probes that they serious game changer. All that math is done for you. and it really
Well, let me ask you this: when we take the wet bulb, why are we taking a wet bulb? What is the purpose? So why, when we tell a new technician that you need to take a dry bulb temperature and a wet bulb temperature, and they look at you with the deer in the headlights look, and go, why? What are we telling them? Exactly. That's what I was looking for. So that's when we're teaching them the basics, but the difference between sensible cooling and latent cooling. You know, the difference between the amount of humidity in the air. You know, the sensible temperature is going to be the temperature that we feel, the one that you see, 75 degrees. You know, but then we have to mix that in with the latent cooling, which is going to be the humidity and stuff mixed into there. And those two things are how we achieve comfort. We should be fine now.
Back
I was playing with
okay.
buttons. You guys good? Can anybody still hear us? It says it's Steve and Gil has audio. So I guess it must have just been you.
Steve is muted or something. LOL.
Weird. No, he should be good.
He should be.
It says Steve not hearing you. I don't know why we don't hear Steve.
Are you pushing buttons, Gil?
I can't. Zach's cracking me up.
Yeah, I was over here playing, but it shouldn't. It wouldn't have done anything to do.
Steve is
I can't
muted.
effing learn. Turn on audio. I don't mean to backtrack, but it was funny when Zach said earlier something about a couple of nice teats on Saturday night.
Yeah.
Audio is
that's another basic thing that a guy, you know what, that we have to add that to the tool list for a new guy. You need a psychrometer, and then there's basic ones in there. I remember, and you got to stick your psychrometer in the correct way, because when I was taught,
got to get it in there too, man. It normally they say 6 inches is average, but you got to get it in there really good though.
Yeah, you got to give her. And because the guy that trained me would stick it on the thermostat. When I first started, I remember that he would take his little, I had a UEI psychrometer, and he would stick it on the thermostat and say, just come grab it later. It wasn't until Bergman told me, no, you got to have it as close to the blower on the return side as possible, or the inlet. And so,
Let me ask you a question, Cory. Where do you measure your return temperature?
Sorry, say that again.
Where do you measure your return temperature?
My return air, I drill a hole that's close to the filter cabinet as possible. So right as the return, see, I have all duct work, so I'll put a hole as close to that blower wheel as I can. Sometimes I'll even just stick it in between the filter, in the filter rack.
So are you taking it in the return plenum, or are you going where you actually take your static pressure measurement?
I'm just drilling a hole right by the filter cabinet. So I'll do a 3/8 hole, and I'll stick my psychrometer right in there.
After the filter?
No. You talking static pressure or my return air?
Temperature,
just right by the, just right on the return boot coming down, as close to the blower as I can. Now, most of my units have 5-inch filters.
Mm-hmm.
So if I don't drill a hole, sometimes I'll literally stick it in the filter. My psychrometer just sitting in there.
You do a lot of, I call them dungeons or cellars, whatever. I don't know what you call them up there.
Basements. It's all basement.
So we got
Dungeons or cellars. I'm not sure what you guys call them. Basements. Yeah, it's the lower level basement. Sorry.
cellar here.
First floor.
But no, we have a lot of duct leakage on the return plenum. And I have seen huge temperature differences where a guy has already put a hole in the return plenum for a temperature, put his little delta T symbol around it. And then I would go into the lower door where I took my static, getting like a 5-degree difference.
Really?
Yeah, because they're not sealing duct board plenums that fall off. They get cracked. They use mastic tape and don't use mastic on top of it, and it cracks. And so, yeah, we get a lot of infiltration from bad places.
Thank God you don't see duckboard around here. I hate that shit. I hate it
I
with
don't
a passion.
see that ever. I don't see flex duct. I don't see anything. I have nice finished basements with ductwork, and it's real easy.
America and take static pressure. You've got
Oh,
it. You've got all metal.
Oh yeah, it's so easy. It's nice.
Yeah, we're mostly metal. Anything that's in a basement is metal. A lot of stuff in an attic is. You do see a lot of attic jobs here, where you see some flex, especially where you get these houses where they should have been built with 2 systems, and they have one. My brother's actually in this situation. My brother's got a great big house. They put in one system. It's nice, but it's hard trying to cool the 3rd floor. You're trying to fight the laws of physics. You're trying to push cold air up the 3rd floor and come down. It's just it's very hard.
That's the biggest battle we have. Like the number one complaint with customers up here is when I ask them, do you have any concerns? And they're like, yeah, like my daughter's room on the 3rd floor is always hot. They say it all the time. And it's such a concern that they never want you to lower their airflow. So if I go to a 2-ton unit spitting out 1250 default CFM, and I'm like, well, I lowered your CFM to match it with the unit outside. A lot of the times they'll freak out. Don't touch the airflow. We can't get air up there. So that's a question I have for Nate Adams. I mean, it must be an envelope issue where you're getting infiltration through something, but it's so common up here.
Or it's just if the system is in the basement and you have a basement, a 1st floor, and a 2nd floor, cold air naturally wants to fall. And you're trying to push it. And a lot of people, they're not floor vents. I've seen some of them where they go up into a hot attic and then come down from the roof. To me, that is the most fucking retarded thing ever. You're setting that system up for failure. To me, if you're over a certain square footage, and you have 3 floors, break it up into 2 systems. I know the builders are never going to do it because of cost. And they're never going to put the unit on the middle floor where it should be because square footage, the layout. Who the hell wants it on the first, on the middle floor? But design-wise, I just think that is better for the system and the comfort for the people. I've never understood that. I mean, that's like townhouses, the chimney effect. They can never, it's always cold downstairs in the basement in the winter, and it's always hot upstairs on the 3rd floor. Oh, but we go downstairs and we shut off all the vents. I'm like, well, that doesn't always work. I tell people, I'm like, if you have an 8-ounce glass and you can pour 16 ounces of water in it, but guess what? It's only going to take 8. So if you have a duct or a boot that's rated for, 200 CFM, you're only going to get 200 CFM in there. I mean, you might speed up your velocity a little bit, but closing off all your vents, to me, I've never seen it make enough of a difference that, it really helps anything.
No.
Yeah.
If you want to do that, you got to put dampers in right at the plenum and hope you can do something that way. Or everybody's favorite, just put a zone system in.
Yeah, well, I agree. That's the way it could be. Rick says, middle floor, are you doing 3-story homes? Yeah, we do quite a few. I mean, I have a 3-story home. That's why I have 2 systems, because it's never, ever gonna work. Albert, I'm glad you asked about that, man. A merchandise order was placed with Adam's in here with Adam's buddy Mike. So we'll have a whole bunch of that stuff soon, man. And I'm not even all that stuff. I'm not selling it. I'm just gonna give it away for prizes and stuff like that. So, and then of course I would give you something, Zach. And then all the people who have been waiting for my prizes, which that's embarrassing. Anyway, all those people are gonna get free stuff too. I'm just gonna give them free stuff. But to answer your question, Albert, I forgot where I was going. Anyway, I got
It's all good. I
got
mean,
dazzled there. But yeah, when the people say the 3 floors, we see that a lot here. Well, when I mean 3 floors, I mean like basement, middle floor, second floor. So it's a 2-story home, not typically a 3-story home.
2-story with
how many of you guys have actually tried a hot wire? Any success with that? No.
It's to me it's too much work. I have one. I've only used it a couple of times, like doing the whole traverse. The it's just
It is a lot of work, eh?
yeah. I think that it's good when you have like a house that like is a lot of duct. Like you have a lot of issues that you got to go in there and really try to fine tune. It's not one of those normal issues that sometimes you got to do it a couple of different ways just to try to compare the numbers to try to see what you got. But me, I would do the, static pressure, the airflow, the air hood route, stuff like that. I think other routes I would take before I did the traverse.
Yeah, it's survival. I've heard the same thing, the 405i. I remember back in my heyday when I was getting a little probe friendly or hungry, I was going to buy that, but everyone says the same thing. It's like, no matter how many times you traverse it, you always get a different number. But
Zach says, Gil used to hotwire cars. I did. It was a long time ago. My brother's watching. Surprisingly, he's not saying anything, but it's not that kind of live stream, but we could tell some stories.
Now
this is a thing I
can't find their keys to.
Yeah, it's way past the what's it called? Statute of limitations, so I'm good.
Okay.
How reliable do you guys think? I remember hearing Bergman and Brian having a podcast on it, but how reliable is the board's CFM output? You know what I mean? If you go up to a board and it's shooting airflow 1000, I wonder how reliable it is.
I don't think that it is. I think that it is spitting out a number that you have programmed it to run at.
Yeah. But if you're on shitty ductwork.
Well, let's do a test. You do one hoser, I'll do one. Next time we see one that has that, let's block off, let's pull the filter out and put a piece of cardboard halfway through it.
Yeah.
Just go ahead and do a test and see what we get.
Yeah. You guys let me know the results of your test and I'll tell everybody about it. Okay.
It's funny you say that, like with the technology. I mean, I know we always say you want to start with the basics with technicians and just show them, but with some of the technology out there, there's like Measure Quick's algorithm for airflow is pretty bang on. It's pretty good for a new guy.
I've never tested against the board. Sorry, Cory. I've never tested against the boards like you said, but I have, like, that we do a lot of Carrier stuff, a lot of the Carrier Infinity, and it gives you the static pressure, it gives you the CFM, all that kind of stuff. We have tested against that, and it's pretty damn close. It's pretty.
I would think so too. Yeah.
Yeah. I mean,
most of the time, like if I'm using Measure Quick, the airflow is pretty close to what the board is saying. So I think if as a basic guy, if you could get the dip switches set, you'll be in.
I would still pull your blower, put your static pressure probes on and check it. and see exactly what you're doing, just to make sure. I mean, it's there. It's in the startup manual to check the static. It just doesn't say set your dip switches and leave. You look on that last page. There's that sheet. It tells you all the things that it wants to know.
Yeah.
That'd be interesting to see. So we don't. Well, the new trains are starting to give us a little readouts, like Linux does. Up until a year or so ago, we were just getting flashes. And
okay. Yeah.
Nothing more than what it was programmed to be.
Yeah. Yeah. That a lot of Linux does that on their units as well. Just flash codes. Each beep is 100 CFM.
Yeah.
But
if you have a clogged up filter, it's still going to give you those same flashes because that's what you set the dip switches to be. And that's, I think, where a lot of this, what we talked about at the beginning, that this variable speed technology was going to fix ductwork, airflow problems. And no, we found out real quick that those problems are still there. You just have a motor that can ramp up and really, hopefully, never reaches 100%. So kind of that.
If we back up a little bit, though, ductwork and static pressure has also been the X13 destroyer.
Yes.
Those people are like, these motors are shit. I'm like, no, they're just not designed to fix shitty ductwork. Mm-hmm. So when you had that, that PSC blower that didn't know any different, even though it kept blowing, you change a capacitor every year, but the motor wasn't bad. And then you put in a system with an X13, you wonder why that motor, man, we've changed 3 of them in warranty. Okay, well, let's start trying to be detectives and stop just replacing fucking parts and figure out why this thing's going bad.
Yeah.
I mean, have we ever walked into a house and said, man, this thing's got too much airflow, too much return? You know what? I meant to say too much return. No, we don't ever, nobody ever says that.
Yeah. We had that discussion this morning on, can you have too much return?
Yeah.
And I say no.
No.
I mean, I think there is that design aspect that Nate would probably go crazy for us saying that, but there are so many systems, particularly down in Florida. Miss Jessica can vouch for us, where they just have one giant return. They got their furnace sitting on their air handler sitting on a pedestal in the garage, and it just dumps one giant return through the lip.
You got to stop putting on a pedestal. Stop putting. Let me ask you guys your opinion on this, and I know we're getting far past basics, but whatever. It's our show. We talk about what we want to talk about. When it comes to returns, do you like the one general common return in like the middle of a common space pulling it in, or would you rather have smaller returns in individual like spaces in the room? Like me, when I did mine in my house, I ran mine to like each bedroom has a small return so that, I have that constant flow of condition and recycle and air. I think that is better for comfort in my opinion. I guess what's yours?
Yeah. Did you bring that up so we can help Zach design his ductwork? I know he's having some back and forth on how to do that. No, I've always been a giant believer in a return in every bedroom, living room, dining room, den. Just keep it out of the bathroom. And that way, when you do close the door, building the giant pressurized room. And I don't know how many homes I've been in where the customer has white carpet and they don't have returns in each of the rooms, and they have this giant line at the bottom of their door, and they want to know what's going on. And the door closes. You can't keep the door cracked. Boom, it slams. See, I've always been a big believer in a return in every single room.
I like that. Chris Young, when you say both, are you saying have them in individual rooms and in the main spaces? Is that what you're saying both to, Chris? Because if he's saying that, then I kind of agree with that. And that kind of goes with the point that we were saying. I don't think you can have too much return. I don't think we will ever have a problem where there's too much return.
What I have in here at my house, and I'm going to fix it one day. All of our equipment's probably not what it should be as technicians. But I have a 6-inch supply with an 8-inch return in a small little corner bedroom. And if I don't close that door all the way, every time that system comes on, that door opens. Because I'm drawing so much more from return than I am putting in supply, that door will actually open. So creating an imbalance. So if you look at it that way, you can have too much return in a room, but not for the whole system. I don't believe you can. That's where the whole test and balance and design comes in. Like we talked about at the beginning, being able to take the static pressure and the supply, the return, and just identify where is a bad area in the ductwork. Turn that over to the design guys in your office and let them go out with the hot wires and the flow hoods. As technicians, we don't need to be out there doing that. We do need to identify it and turn it over to the office if the customer wants to pursue it. Obviously, we've got to let the customer know. And generally, they think that it's going to be a free thing. Oh, they're going to come out and they're going to do all this testing. No. I don't know about, do you do testing, Gil?
Not all the time, and to be honest, probably not as much as we should sometimes. But I do look at a lot because you guys know that I like to sell high-end systems, and I'm not going to sell that if I know the ductwork can't handle it or there's going to be an issue. And most people realize, especially the people that want those nicer systems, they don't want to spend. I just tell them flat out, I don't want you to get this, and I know it's not going to work right. I know you're going to have problems. You're not going to be happy. You're going to do it without doing these modifications. And if you do it without those modifications, you're going to call me back and be like, Gil, what the fuck? So I don't, and most people are like, oh, that makes sense. Let's fix it. So I guess I do some testing. I think sometimes maybe I should do a little bit more, but I think I do enough to get the job done, which I guess isn't really a good motto, but.
What about your technician? They're out, are they checking static? And if they have a customer that says, yes, I know my home is, something's not right here, the tech finds you've got static pressure issues due to the ductwork, the coil's clean, they've got a nice big fat air filter, so that's not a problem. They just find that the ductwork is too much flex, kinked.
My senior techs are.
So, but do they do the work, or they turn that back over to the office?
They'll do the work, or they'll turn over their findings to the office, and sometimes I will put together a plan of attack and then have, one of the install teams go out and perform the work. Yeah. Depending on what time of year it is, maybe they will fix it. If they find it, and I'll say, hey, well, what do you need to do the job? We'll talk about it. And then I'll be like, all right, I'll have so-and-so bring out what we need, start doing this, start doing that, and let's get it done. So it depends on the time of year, but like this time of year, normal circumstances, we'll go over their data. They'll bring it into the office. We'll go over it, maybe put it into a few applications, see what comes up, that kind of stuff, and kind of put together a plan of attack.
There you go.
Hey, little lady.
As the technicians, where is she? There she is.
Here's one. So that means they said that Daddy only has till 10:30, and at 10:30 we have to
send in the troops.
Yep. We have to turn the stream off because Uncle Jason's out there watching. Say hi, Uncle Jason. Okay, or say nothing.
It is 10:31. They're right on time.
Yep. So, yeah, let's go ahead and end this. I think this is a good conversation. I definitely think that this is something that we should pick up. Maybe next time we do this, we'll call in. If you guys want to call in, I'll turn the phone on and let you guys call in. It's just a lot of times when I do that, nobody ever calls in. So, Hey,
She finds it funny.
yeah.
Not funny.
Yeah, that's me. But yeah, you guys can call in and ask any questions and all that kind of stuff. We want to do that. We want to talk to you guys, and we can just cover different issues. You guys call in and ask different questions, and we'll give our best opinion. Maybe we can answer it, maybe we can't. But if we can't answer it, maybe we'll learn something. Between all of us here together, it's a lot of knowledge. Uncle Jason said, "What's up, girls?" Oh, Jesus. Normally they'll never be quiet, and now it's just, yeah. Ugh.
Camera shy.
Yeah.
I get it.
All right, come on, back up. But as always, man, thank you fellas for being here. I appreciate you guys.
Always a pleasure. Thanks for the guys watching, girls watching,
Yep.
everyone in the chat.
Yeah, of course. Thank all you guys in the chat. Thanks to moderators. Thank you, Rookie. Appreciate you, brother. Thank you, Bill. I'm not sure what the other moderator in here was, but thank you guys. I appreciate you. Thank you guys for being here every week, man. We really appreciate you guys being here. We know it's pretty much the same people. And yes, thank you for being here. Thank you, gentlemen. And I will see you not next week, but the week after.
Every other week.
Got it.
Yep.
Got it.
All right. Have a good night, everybody.
Y'all be safe.